Welcome back to the Mom Mentality Show. My name is Austin Chadwick and my co-host is Chris Lucian. And today is going to be a very fun discussion with James Grenning on a whole host of interesting topics, including TDD, zombies, embedded, legacy, self-paced training. We may not get to it all, but we'll talk about some of this stuff and see what happens. So with that, James, can you tell us a little bit about yourself?
Yeah, let's see. So, well, the story can be kind of long, so I'll try to make a really short version of it, which is back in the 70s, a friend of mine was programming in high school. It looked like a horrible thing. I tried to stay away from it. And then all of a sudden, one day I tried it. It was really fun. And so now here I am today. I got involved in embedded systems. I'm an engineer, right? I wrote this book, Test-Driven Development for Embedded C. I've been involved in some cool stuff over the years. Been fortunate to be at the right place at the right time.
Nice.
So
yeah, and what's your experience with mob or group programming?
Oftentimes, if I'm teaching a group of embedded systems developers how to do TDD, we'll usually pair. Well, in the day of when we could be together, we would pair. And then after a couple of days of intense, here's what test-driven development is, and then they're saying, I think that could help, but here's our code over here. What should we do? Then we would mob on that code. Usually in a very loose kind of mob because no one was set up. I don't want to put a prerequisite in front of people to say we've got to be able to make it so that everybody can use every keyboard. And like everybody's got a different keyboard, so no one can actually switch efficiently. So my mobbing experience is kind of minimal. I do enjoy when I get to work with other people because I learn a lot. And so I'm totally an advocate without being able to do it as much as I might like to. And then one of my first experiences was at a company where I think you guys know, Hunter,
yeah,
right? And I saw what you guys were doing and it was amazing. And I asked your product owner what he thought of it. And he said, well, it seems kind of strange to me that they always work together. But they're never stuck on anything.
Yeah.
Every week they're solving a new problem. And then Chris shows off the no bugs bug list. So that was so, I tell people about that all the time. It's like very impressive because most people don't believe it's possible to not have bugs.
Yeah. It's a thing that I think TDD doesn't get a lot of credit for because I think a lot of code bases don't ever maybe make it to that level of coverage, right? But I've seen it in action and it's fantastic.
Yep.
Yeah, and maybe that draws us right in the first topic of TDD. Yeah, and I'll second that. I mean, I'm currently working on a code base that was TDD from the start, and man, it's a nice place to be. So yeah, what was your introduction to TDD, and what led you to write the book and all that?
Yeah, so 1999, I'm kind of an inexperienced guy with 20 years at that point. And I had spent about 20 years in embedded systems development, leading groups, also managing some groups, also doing some kind of field marketing almost, till I ran into this GM, which I learned a lot from, but it made me realize I didn't want to be in the corporate world anymore. And I joined Bob Martin, who we used to work together a lot. We've been colleagues since 1981, I think. We worked together at the same company in the 80s. And then in the 90s, he was saying, you should come and join me at Object Mentor Associates. And so eventually the time became right and I went and joined Bob there. I'm telling you the long story. 1999 now, we have extreme programming is being talked about because of it's one of my theories is because of its provocative name. People are talking about it and making jokes about wearing helmets and elbow pads while you're doing your programming. And I'm watching Kent demonstrate test-driven development up on a big screen with about 50 people in the room. And he's running his code in JUnit. And mentally, my jaw dropped because for 20 years before that, what us embedded systems people had to deal with was writing code for something that didn't exist. And inevitably, the deadline would approach, the hardware and the software would meet, nothing would work, the date would be way in the past by the time we got things to work. And here's Kent getting high confidence in his code in a test environment. And that was like, oh, this would be great for embedded systems. And that started my journey. The next Monday I was with a client and we started doing it. They were like, what? That couldn't possibly work. No. And it did.
Yeah. Well, you know, I've kind of witnessed this firsthand, but I've seen people kind of resistant to the idea of TDD in some level, and then kind of come out from a discussion with you on how it can help in an embedded environment, and then kind of convinced completely the other way. And so I've seen some of your talks and some of the tooling around it. So obviously, like in embedded systems, the tooling is not exactly the same, but you know, I guess like what sort of hoops does somebody have to go through to get TDD into an embedded environment, just for those that might be listening on that?
Well, the first thing you have to do is stop running your code in the target, because you don't have a target.
Yeah.
All right. So the first thing we want to think about is, how do we make code portable?
Yeah.
And actually, this is done in the small, right? It's like, we need to work on something. It's written in C or C++. Guess what? Those languages are supposed to be portable.
Yeah.
They're portable if you work like crazy on it. Okay?
Yeah.
But everything's made out of them, right? Made out of that platform. So one of the things I try to break people's mental block with, and I survey people before my training classes, of where do they run their code? And you can go look at the answers on my website, and almost everybody runs their code only on their target. And that means if they don't have a target, they might use an eval board, right? Which is the same hardware or similar hardware, but without the peripherals.
Yeah.
So they might run their code in something like that. But really, all those are temporary things that they might do. And then anything they did there gets thrown out.
Okay.
So one of the things, and people live with long cycle times to be able to get feedback. And so one of the things that that I try to get them used to in the first exercise is nearly instantaneous feedback on each little step they take. And then the first reaction after that will be, so see, we couldn't possibly do this embedded because our cycle time's a half hour. It's like, well, that's not a problem with TDD. That's a problem with your production build. And actually, that's not relevant, because what you need is a unit test build.
Yeah.
And you could say this about any environment. You know, if your dependency is on a web server, you have the same problem as if your dependency is on an embedded target.
Yep. That
dependency means you got to run your code in this foreign environment, and it takes a lot of time. So separate your code, run it independent. Later, you could run your tests in the target as well, if you felt that that was going to help you. And there's some reasons to. I've got a chapter in my book about why you might want to. But generally, as an engineer, I don't want to solve a problem I don't have yet. So, you know, that might be a portability problem that makes you want to run in the target code, in the target hardware.
Yeah. So when you're mobbing, do you see these lights go off and like, you know, mobbing this for the first time, or how does that play out for you? I know that you pair maybe initially or and then kind of go into loose mobs. So what's the dynamic there when you're kind of expressing this? And
you mean, so after I'm with the group for a few days?
Yeah.
So well, the first experience always is kind of shock and concern about what test driven is, and it's going to take them too long, and it's, you know, they won't be able to do it. And then after a couple more cycles in my toy examples, they start to realize, it's really hard to get even simple code to work right.
Yeah.
How could my complex code work right? Maybe I should be afraid to not have tests. Right about that point, when the planned training activities end, then we go into their code. And we usually, somebody doing embedded systems has never had their code in a test environment before, and it has concrete dependencies on the execution environment, the hardware and the real-time operating system, or whatever it might be. And so we have to drag that code into the test environment. Now, usually people want to give up in about 15 minutes.
Yeah.
Okay. But I've got some experience with helping them through that. I show them what's going to happen.
Yeah.
We're going to be fighting the compiler for a while. Okay. Once we get the header files for the test case to run, then you're going to want to build your production code, and then we're going to go have a problem getting it compiled again. We're going to go through this loop, and eventually you'll get linker errors for your dependencies. And when you have the linker errors for the dependencies, then you got to go deal with all those linker errors. Now I've automated this next step where you can look at a link output map and turn it into what I call exploding fakes. So a test stub that if you happen to execute it, it will terminate your program immediately, and you can see where you were. And the message that comes out is says, you better go write a better stub for log debug, right?
Nice,
Which is the first thing we hit is a log debug message usually.
Yeah.
So go write a better stub for that. Well, let's just turn it into a null stub for starters. Okay, then we get a little bit further, we hit another one. And as the code starts executing, the ones that you care about, you bump into in the code path you're on. Yeah. The other ones are sitting there guarding any dependency that you have in case you bump into it by accident. All these other linker stubs are there, will explode if you bump into them. But now you're making your test smarter as you work your way through this process. Yeah. I've got a web page on it. I call it Crash to Pass.
Nice.
I wrote about it in my book, and it's basically you got to solve a whole bunch of really little problems till you have even a stupid test case that passes, and that one might take you 5 hours, but the second one takes you 2 minutes.
Yeah.
Right. And so you got to pay that first thing, and then you're going to be able to live in the freedom. So people find that kind of that it wasn't that bad. Yeah. And now we have our code in the test environment.
Nice.
Right. And so the price was painful, but
yeah. So I mean, that's a really good coaching technique in general is the anchor, anchor with kind of like what's coming up next. And so that people aren't surprised by it. Yeah. So Austin, do you have any questions?
Yeah. My question was, so it sounds like your training is not just like, oh, here's TDD, here's some toy problems, bye, see ya. Does it usually involve a day of like, here, I'm going to help you set it up in your environment?
If I'm with a client live, yes.
Okay.
But now with, like I do a fair amount of public courses.
Yeah.
Usually one a month or a couple of quarters, something like that. And with that, we can't go into anybody's code, but I have example code I go through to show the process. Now the process is super boring. Okay. Oh, I got another compiler error about a missing header file. Where is that file in my directory structure? Okay, not very much fun. And so I've started writing this script that when it runs into the well-known error, so what do you do if you run into can't find an H file? Well, you go to the command line and you do a find for that file and you find it. Well, my make file now goes to it pulls out the stuff out of the error message and finds a missing file and then goes and looks for it in the directory hierarchy. And there might be several of them. And it gives you the list of them with the exact thing you need to paste in your make file, into my make file.
Yeah.
To make the next, to continue the progress.
Automate the
so you can take this, really boring activity and make it kind of like just, oh, I'm solving one problem. I changed the error message. Yay. One at a time. And then when you get the link, so typically that process to make it interesting for a group of people watching, I have to make it uncharacteristically short.
Yeah.
3 header file problems, 10 linker errors instead of the usual 50 header file problems and 200 linker errors. Right.
Yeah. It's like the baking show where they like put it in the oven and then they step over to the other oven and pull it out. Right.
It's not exactly that. It's like just making really tiny cakes that can cook fast. Okay. So kind of like that. But if anybody of your watchers are interested in this scripting, I call it Gen X fakes. Nice. No offense to the Gen Xers. It's Gen X fakes. It stands for Generate Exploding Fakes. Yeah. And so I'm kind of growing this thing, which is pretty handy. Well, I use it in my training, and a couple of other people are using it in their quest to get their code under control.
Nice.
Yeah.
Well, what stood out to me was TDD training or adoption or persuasion, and the very human side of it, that just having someone there who's been through it before to guide you through, the 500 compile errors. I had a similar experience where someone was, it was a previous place I worked where we talked about TDD and unit testing, and on this team working on legacy code, there was one person who was interested. And so we went and paired together. And the first thing we tried to write a test in their gigantic project file that had dependencies on the world. And the first thing we got was 600 compile errors. And I think if he was alone, he probably would have given up, as I would.
Yep.
But the two of us there kind of motivating each other, like, okay, well, let's try to figure this out. We figured out a way to separate the new feature he's working on into a completely independent project, and then he can unit test that and then integrate the project, kind of thing. But I think that I find that admirable that when you're working with people, you're willing to step into their code base and help them figure it out. And so I find that really cool.
It's kind of interesting. It's one of my clients that made me do that the first time. About 10 years ago. And they said, okay, yeah, we'd like your 4-day training class. You should just do 4 days of training. They said, but stay an extra day and help us, get it started. It's like, sure. I was like shocked at how hard it was to get their code, because my toy problems, it's all easy because everything's greenfield.
Yeah.
And then when we get into the real world of their code base, which was never intended to be anywhere near a test environment, it was just, I did about 10 different courses with them. Each time I ran into a different thing, and I started writing up what to do about it. And so I've got a collection of all these deeply embedded things you're going to run into. The code just doesn't want to be in an off-target test environment, and all the engineering techniques, hacks you have to do to get it in. But, that's part of it. You hack it in, and then later, that's everywhere you hacked, you need to go back and make an improvement, right? And so if you do this hack, engineering technique, that means you probably have this problem to solve in your code base, this design problem. And so it's been very interesting, and it could be another book.
Yeah. So I'm recently have been working on a legacy code base, and I find myself kind of doing the exact same thing with the mob that I'm working with, is just kind of digging, very, very deep, and then extracting things out and resurfacing it toward the top and gaining control. Right.
Oh yeah.
That's really good. One thing.
I went to Llewellyn Falco's approval testing course a couple weeks ago. It was really good. Yeah. And he has a name for what you just said. He has one thing, which is peel. You try to peel off something. The other one is slice the thing out of the middle. And so you both talked about pulling something out of the middle.
Yeah. In fact, I think I did that training with him 8 years ago, I think, maybe somewhere around there. And and I've been using that technique ever since. Cool. And then, one other thing that I often quote you on is the zombies technique, which when I heard that from you, I was like, this is fantastic. So I quote slice and peel and zombies like all the time. Yeah. And so, I don't know, maybe you could describe to the audience what the zombies technique is.
All right. So zombies, well, in my book, so back in the beginning days of watching people do TDD, Kent Beck and Ward Cunningham and Ron Jeffries demonstrating it. One thing that they always started with was a ridiculously simple first test. Mm-hmm. Like, okay, we have a stack. Yeah. How many items are on it? None. Return 0. It's like, what? That's ridiculous. And then they put something in it. And then how many are on it? There's 1 now. Okay, what if you popped it? Oh, yeah, I get that back. It'd be empty now. It wouldn't be empty. So there's this kind of growing things from complexity. And when I was writing my book, it's like, I'm thinking, this seems like this 0-1-N is what's happening. You start off with these 2 simple things, and then you generalize later. And so I wrote about 0-1-N. And I was talking to my friend, Tim Ottinger.
Yeah.
And Tim says, oh, there's a name for that, ZOM. ZOM, 0, 1, many. And then he went on to explain in computers, there's only 3 important numbers. 0, which is a special case.
Yeah.
1, which is a special case. It turns out this is true in math too, as I understand it. And then many, it's like 2 isn't a special case. No, 2 is the first of the generalizations. Oh, okay, that's interesting. So ZOM. And now when I've been explaining to people, so here's my situation where zombies came from. When I teach a training class, The first test-driven development experience people have, then they have to answer 3 questions for me. What did you like? What are you concerned about? And what surprised you? And they all tell me something they like, which usually, that's not the important part. The concern is the important part, to get that out.
Yeah.
The like is there just to show some positivity. I learned this from one of my clients too.
Yeah.
But then the concern was, how can I think of these tests? How will I know what test to do next? It's like, well, okay, here's how I think of them. There's 0, 1, and n. We start with the really simple things and we work our way up. And then everywhere you've sprinkled in a hard-coded thing, that's a key of where you might go next. So you start to, like, so in a stack, it's empty. And so we could hard code the size as 0 and we could hard code true for is empty. What do we do next? Well, if we push something on the stack, that would make the size go up and it wouldn't be empty anymore. Oh, okay, well, right. So this kind of leads you, the thing you left open leads you to the next test. Now you might have several things left open, right? In which case some you do now and some you do later. And I call it skillful procrastination. What are you going to do now? What are you going to do later? And then as you're talking about what you're thinking about in the different tests, during 0 and 1, you're usually defining new interfaces.
Yeah.
And so the interfaces don't exist yet. And did you ever get together with your friends and design interfaces on a whiteboard and then go off and work independently and then bring them back and find out nothing is easy to use?
Nothing matches, yeah.
Nothing matches and nothing's easy to use.
Yeah.
Well, the test case is the first user. So you're doing interface design. So that's the I in zombies. So while you're thinking, so it's not your normal acronym where you can go like this.
Yeah.
You got to do 0, 1, many, and then BIES, and it's like a matrix.
Yeah.
But with S in the middle, keep it all simple if you can. But so you're thinking about the interfaces and you're capturing boundary conditions. So the B in zombies is about boundaries. It's funny, I was just using all these words before ZOM ever was there to describe how I'm thinking of the test cases. And so when ZOM happened, it's like, oh man, this is.
You have a natural progression from here.
Yeah, it's a natural. Now it's like, okay, now you're going to be guided by zombies.
Yeah.
E is this thing, and kind of go back to the early days of learning. It's like when you think you're done, take a step back.
Yeah.
And look for the exceptional things you might have forgotten. What did you forget? And then the S is about keeping it simple, keeping your scenario simple. And so that's where that came from. And that kind of can help, that pattern of progression through the code can kind of help you think of the next test, right?
Yeah.
Yeah.
Great.
Yeah. I mean, that acronym has really caught on with a lot of people I work with. It's funny.
Cool.
I think someone who was an embedded engineer and then was doing non-embedded coding with us, he taught it to me when I was mobbing with him, and it became like our mob's working agreement. Like, oh, when we write the tests, we go through the zombies before we move on, And so, and then we had a visitor and someone else was explaining to them something, and then he's like, oh yeah, and then you do the zombie thing, and I'm just like, oh, do you mean James Grenning zombie? He's like, yeah. And so I think it's really catchy, but it also really helps you walk through all the important things. Because I mean, for me, that's one of the safety and the comforting things of TDD is I know when I ship this feature to production that we've covered the 0, the 1, the mini, and the exceptional. And sometimes there's things you don't think of, and that's all right. But at least you've handled the main stuff. And so every time that suite of tests runs, I know all the zombies are slayed. Is that how you think of it? I don't know.
So when I wrote we're coming up on I don't know which year anniversary of writing the article, but I did publish it on Halloween a few years ago.
Nice.
It was like, I was working on it about this time and I'm thinking, oh, well, let's do it. Definitely put it out there on Halloween because
that's fantastic.
So what was your question?
Oh yeah, no, it was more of a comment, but yeah. Any questions on zombies, Chris? I had one on TDD, but
no, go for it. Let's talk TDD.
Okay, yeah, let's go.
I lost my train of thought, but
yeah, no worries. So going back to TDD, introducing TDD to people is tough, And then I think it's probably particularly tough for an embedded environment. I think we talked about some of the unique challenges, but what are some of the other biggest barriers you have with introducing TDD into an embedded world?
Well, I think it's one thing is, engineers think they know everything, which is okay. I remember knowing everything too.
Yeah.
I've learned a lot since then, but that's a joke. I know it wasn't that fun. But no, so we come into this as skillful people, and we've done our job and we've been really good at it, and it's a hard job to get the thing to work at all. And so now here's this guy coming in and telling me how I should program. So there's always a little bit of people are reluctant. You need a motivation to change, and in the beginning, the motive, what we thought is after we convinced ourselves it was a good idea, the Bob Martin and the gang at Object Mentor, if we kind of convinced ourselves, and we thought if we tell people what it is, they'll want to do it. It turned out, no, they don't care about what it is, but they do care about problem solving. And so what I like to do to get people interested in writing those tests in my first exercise is related to a problem, like my code doesn't work. Is this doesn't work? Oh,
doesn't
my
work.
code works or my code doesn't work. Okay. I want my code to work on purpose, not by accident. But so if the problem that people, I've got a different shirt here about bugs, which I might have put on too. It's like being the investigator in the crime where you're also the murderer.
Yeah.
Is that shirt. You probably heard that one before. But, so if I can get people to say, yeah, I do write bugs, and actually ask some questions before the course, so they tell me the answers before they know that I'm going to use them against them. Now I'm spoiling it for anybody that's listening that might come to my course. But do you actually think you write bugs, right? I mean, will you admit that you do? Would you like to write less of them is kind of a proposition.
Mm.
So before the training class, people say, two of my questions are, what do you like about development and what don't you like? And I offer kind of a vague value proposition of what if you could do less of what you don't like and more of what you do like, right? I like problem solving, I like coding. I don't like chasing bugs. I don't like being late. What if you could do less of chasing bugs and being late and more of problem solving and writing code, right? That's kind of a basic value proposition. So they say, okay, I'll listen, right? And so people will go through the experience and then they'll be like, oh no, this will never work. And then kind of helping them through the concerns after that, because the concerns are often valid, but often through experience you discover that they're not. They're an initial concern, like I think it's going to take too long, and then later you find out, well, actually it's faster to not chase bugs.
Yeah.
So I kind of get people to try it, by suggesting that there's a problem we want to solve. This is kind of if you wanted to go down a rabbit hole, we could talk about what's wrong with Agile, and but maybe we should do a different talk.
Yeah. maybe a little bit later.
What problem are we solving? As an engineer, I want to be solving a problem that I know of, and if there is a problem that I can identify, then I have a chance at solving it. Yeah. Right, and that's if it's a solution, TDD is a solution. Nobody's asking what problem. Scrum is a solution. What's the problem we're trying to solve, right?
Mm-hmm. Yeah. Mm-hmm. Nice. Yeah. I guess the follow-up question I had too was it's pertaining to a conversation Chris and I had earlier in the year with someone who was talking about development cycles with hardware, firmware, and software. What have you typically seen to people's development cycles once they adopt TDD? As far as typically I've heard, like, traditionally with embedded, your development cycles are you kind of sync up with the hardware at every couple months or something like that, right? Yeah. So what's been the impact on development cycles, feedback loops, and that kind of thing for embedded teams that have started adopting it? Yeah. So
I try to stay in the world that I know, which is the software side, although I know a little bit about the hardware side because I've had to interact with it.
Yeah.
And I realize your last question was about specifically embedded, but I don't think there's a specifically embedded thing that's difficult for TDD. Okay, because I think it's a general thing that's different. Okay. But now how did things change? I can go back to the first project I worked on. It was at a big company, and we were one team having to integrate with many others. And they really valued their waterfall. They had the heaviest ever process you'd ever want. Um, and, lots of gates, 25 gates, I'm sure, through the development process. And, so we were planning using stories, and we could move stuff around. One of the managers in the group that I was coaching, he would get in trouble with his other managers because the other guys would be playing schedule chicken or something, saying, well, we've got an integration problem. We got to move this out. And then they're thinking that they're going to have to hit it back to him and he's going to have to stall. But he'd say, no, we'll move out. We'll change that to that iteration. That's no problem. Just moving stories around. And it was really kind of infuriating for the other groups because it was just no stress for us to reprioritize. Right? We didn't have to do everything the order the PERT chart said, which was what life was like for the big planners. Is you got to know your dependency chain, right, and the order of everything. So now mix into that when hardware is going to be available, right? And so if the hardware has an availability date, right, we can aim our iterative cycles at having something meaningful for that release, for that hardware availability date. It isn't a product release, so so one of the faults of Agile and Scrum is delivering value every iteration. Well, if you don't have anywhere to deliver it, why are we here? Well, because you're trying to show your progress and show the value to your company that you're developing, right? And so you want to meet those integration dates, right? And so this is one of the things that would be different, is how do you do that planning? Really kind of fun environment I was in with a company that was making slot machines. And you had to bring together artwork and music and, play sequence and odds and payouts and all this kind of stuff. It was very interesting. The software was kind of the critical path, but you had to know when artwork was needed. So an artist could have preliminary drawings, right? So same kind of thing is your integration with these other things, because of the flexibility of iterative development and, the extreme programming engineering principles, we can change the order that we do things. Right now, you're so constrained. We can't test on the real hardware until there's real hardware, but we can get very ready for that to the best of our understandings. There's a half a dozen stories on my website about embedded engineers that took my course and then later got to experience this thing. And then it's like, yeah, we spent 2 days integrating, and we were 3 months ahead of schedule then. It's like, that never happened before. It's like, I'm not going to promise that to everybody, but at least one person wrote me that story.
Nice.
So.
That's great. And it wasn't in an embedded environment for me, but I think ever since whenever I'm on product teams that have TDD and there's an integration point or a demonstration or some sort of time where you're showing what happened, right? Or what was accomplished, the level of stress is just so much lower because it's just like, oh yeah, either it's we know it's going to work, or if the integration doesn't work, it's usually like, oh, that one thing's off. Okay, fix the test, fix the code, done. Okay, and I think, yeah, those integration days or demo days used to be way more stressful.
Right. And there is some, with rapid prototyping now,
yeah,
some things have changed a lot in the last 20 years, where maybe you'd have to wait 6 weeks for a board. If you're willing to spend some money, you can have one in 2 days. So Agile hardware. So one of the influences of Agile software development in the embedded world is the hardware guys start to think of what they might do too, right? And so there's things that they could do. And I know we were doing some of the stuff back in the late 80s, like we're going to have 2 chances with this board. So let's put a lot of the logic in FPGA so we can change it. Right. If the board pinout doesn't change, we'll be okay. But this logic that's kind of challenging, let's make that changeable. Right. And so you're basically trying to make I think the lean people call it reversible decisions. Right. So you make your decision at the last responsible moment. You go to that board to production at the last possible moment. But you'd also like to be able to change things. was reading about chips, so when you get an i9 processor, it just happened to be on the same die as all the i5s, but more of the cores ended up being plausible on the on the wafer, and so they have a process then where they go and check the chip out, and then they can disable the ones that don't work, which is as a layman's understanding.
Nice. All right. Well, we're coming a little close to time. Chris, do you have any other questions?
I just wanted to hear your thoughts a little bit on self-paced training. So I'm big into kind of like training and coaching and stuff like that. Yep. So maybe what's a 2-minute succinct thing that you can kind of tell all of our listeners?
Yeah. So I'm working on a course, and it's going to be modeled after my course.
Yeah.
It'll involve watching short videos, and then watching a problem introduction, and then doing some programming in my Cyber Dojo system, and then watching me do it, because I won't be able to give them feedback. I do a little bit of automating of trying to catch them writing more code, so through coverage analysis and such, try to give them instant feedback that they're not doing TDD when they write the whole thing. Now I just was talking to a friend of mine who was saying, yeah, we did a lot of this and the completion rate was low. That makes me kind of concerned. If people will buy my course, that'll be nice. I'll, be happy to keep feeding my family and that sort of thing. But if they don't finish it, they're not going to get the value. Okay, so I think I've got a pretty fair formula. So in the self-paced training, they'll do an exercise, and then what I'm doing right now is I'm doing all the exercises myself again and recording them, and then going back and making them kind of concise, not watching people see all my typos. I let them see some of them. And then I'll annotate, or I'll go through the thought process, right? So if somebody really wants to learn about TDD and hear how you work your way from one part of the problem to the next, that's what my training will be about. My first offering will be, it'll take probably 2 full days for someone to go through it. It would be best if they spread it over a week. And that will give them, what is TDD? They'll have a good experience at it. There'll be a couple of follow-on exercises. Mm-hmm. They'll get to hear what I have to say about their concerns, because I've got a number of concerns videos, questions I've answered over and over and over again for the last 10 years. No disrespect meant. I mean, your questions are important, and it's important to get an idea of how a test-driven developer thinks of them. Yeah. And then they do another cycle of the exercise. And unlike my live class, when I'm with you, we run out of time. And so in the self-paced class, you can actually go a lot further. So I'm going to expand the example a lot closer to the edges of the embedded system, so that people will get a better feel for what that is and more experience with it. And I kind of walk them through the, why are we doing this thing next and that sort of thing. So I'm hoping people will like it.
Very cool.
Got another idea for a course, which, considering a lot of the words around this are all the same. And then when you mention C or C++, that's the special part. I might make an intro course for anybody in any language, right? Yeah. That they might want to do, because Cyber Dojo, I have setups for Python and Ruby and C# and Java. And, so if somebody wanted to learn about TDD from me, they could do it in the language of their choice.
Nice.
Yeah. So that's
very good. Thank you for the explanation. It sounds really interesting. I like the idea of the automated feedback. I think that's something that is missing from a lot of different systems out there these days. So
yeah, the automated feedback. I know. Now that you say that again, I realize the part that you asked I didn't answer. So I have in my Cyber Dojo system, in the first couple exercises, in the background is a coverage check.
Yeah.
And if somebody trips the coverage check by writing too much code before the test, it will say, if it turned green, right, like I passed the test, but they just wrote too much code, I'll filter the results and I'll say, yeah, you passed the test, but so what? You wrote extra code. Yeah. So you're not doing TDD anymore. And then they get the coverage thing, and they can see the lines that were extra. I also have a filter in there. No, people don't trip this very often, but if they start putting printfs in,
yeah,
like, why are you putting printfs in your code? You should be keeping your code simple so you don't need them. And if they're debugging, it's like, now that you've seen a printf, why don't you revert to the last time your code worked and try again? Because you're not going to probably make the same mistake the second time.
Yeah.
Nobody wants to do that because we're too stubborn.
All right. Well, this was really fun, James, and we're glad to have you on the show here.
Yeah, thanks.
Awesome.
You guys are great.
No, I think, so I think that we'll call that a wrap. I guess, so we'll plug your book. We'll plug your self-training course here, and you as well.
Thanks.
So we definitely had a good experience with your material and your training. And yeah, go ahead.
I'll send you some URLs.
Yeah, perfect.
In the notes.
We will definitely put them in the show notes. And with that, please like and subscribe and reach out to us on Twitter, YouTube, and more, and give us your comments and feedback on guests you'd like to have, topics you'd like to cover. And please share this video with anybody you would think to hear James's thoughts on these subjects. So until next time, have a great one, everybody. See you later.
Bye, everyone.
Cheers. Bye.